G'day again. So this time we're going to do harder integration, and I've called it integration 2, which is very creative. Okay, so we've got this question, and you can't just integrate it straight because it's a bit of a mess. So you have to use a substitution. You're either given the substitution or you'll have to figure it out. So if you were given it, it would be, this would be a substitution. So u would equal x squared minus 1. Okay, so from there you would then differentiate that. You get du equals 2x dx, and substitute this part for this part in the question. Okay, so that plus that is du, and that is your u. So we end up with u to the square root, which is u to the half du. So du is 2x dx, so 2x dx, and there's u to the half. So this becomes a very simple integration. That equals u to the 3 on 2 over 3 on 2. The 2 will come up the top. So we'll end up with 2/3 u to the 3 on 2 plus c, which we'll do in a moment. But we'll substitute back in the value of x, the value of u, which is x squared minus 1. So this will equal 2/3 x squared minus 1 to the 3 on 2 plus c. And there's the bell, and you're done. G'day, back again for question 2. So you'll notice with this one, a little bit of a change from question 1. There's no squared there, and I've wiped out the 2. So we're going to do the same thing. We're going to let this bit equal u. So u equals x minus 1. Same next step. So du equals 1 dx. You differentiate that, you get 1 instead of having an x there. Now there's a problem, because this is u, which is fine, but we've still got this x sticking around. So to solve that problem, we're going to reuse this. Okay, so we're going to have u, add 1 to both sides, so plus 1 equals x. We're going to put this bit here. So in the equation, when we swap over, there's no x's. So we're going to put that where that is. So we're going to get the integral of 1 plus u multiplied by root, well, u to the half du. Okay? So now to do this, I would expand that. So you have u to the half plus u, you can say to the 1.5 or 3 on 2, whichever one makes you happy. So 3 on 2 or 1.5 du. Now I'm going to integrate, so raise it to the power, new power underneath. So u to the 3 on 2 over 3 on 2 plus u to the 5 on 2 over 5 on 2 plus c. I can leave that off for the moment. Okay, so we have this. Move the 2's up the top and substitute back in your u value. So you'll end up with u, which is x minus 1. Move the 2 up the front, so we'll have 2/3 to the 3 on, whoops, not 3 on 3, 3 on 2, plus 2/5 x minus 1 to the 5 on 2 plus c. And you're done. G'day again, back for part 3. So for this one, we're going to look at integrating sine squared x dx. Now this is straightforward, you've probably looked at it in your textbook. If you haven't, this is how you should do it. So the first thing is, you can't just straight away do that, put a squared in front and differentiate it, integrate it like it was a x squared or anything. You have to actually do it so you've got a simplified trig function. So either sine x, cos x or tan x or something like that. You can't actually do that straight off. So what you need to do is change that using cos 2x. Okay, so you should know, or you can rearrange it so that you get cos squared x minus sine squared x. And if we just keep this going so that we only end up with sine squared, get rid of that. So that's going to be 1 minus sine squared x minus sine squared x. So that will be 1 minus 2 sine squared x. We're going to actually switch these over and have 2 sine squared x equals 1 minus cos 2x divided by 2. So I end up with a half minus a half cos 2x, and this would be my side working for that question, and then substituting that straight in there. So then I would have the integral of a half minus a half cos 2x dx, and now it should be a straightforward integration. Integrate a half and we get x on 2. Integrate cos and we get sine, so that 2 there will go in front underneath, so we'll end up with minus a quarter sine 2x plus c, and you're done.